So how do you get started? How do you bring local processing to these edge devices? Well, that will depend on the type of solution you're trying to build. What you're seeing here, for instance, is just a few examples of solutions that have been built with Windows IoT in fields as diverse as energy, healthcare, and retail. But your particular choice of an operating system will depend on what you're looking for in that operating system. Let's look at some of the strengths of the operating systems currently running on the edge. On one hand, you have Windows IoT, which is a great match for heavily regulated industries where you require world-class security and enterprise-grade management to build interactive UI applications that are deployed in situations that require long-term support of up to 10 years. On the other hand, you might be using Linux, which has proven to be extremely flexible and adaptable for low-power environments and a great companion to AI workloads with its low cost of entry. Or you might want to go with Android, which delivers a rich UI experience on mobile devices. There are many options on how to choose. Well, what if you didn't have to? What we're doing with Windows IoT Eflow is bringing all of the strengths of Windows IoT and the flexibility and AI familiarity of Linux together to build a common platform where you run Windows systems side by side with a Linux VM that has been highly optimized to run, taking advantage of the hardware accelerator that's provided on your platform. That hardware accelerator ensures that the modules that are available and running on these IoT modules are able to deliver real-time AI accelerated workloads for you. Let me show you how we do that. In the Eflow T4 demo, we're going to be seeing how we can leverage an Azure IoT Edge device running on top of an NVIDIA T4 card to deliver object detection and detect traffic patterns on some simulation videos. Now, the deployment assumes the existence of a Windows IoT device that is going to be managed from the Azure cloud using Azure IoT Hub, and we'll be deploying containers, amongst them the NVIDIA DeepStream container for object detection, directly onto the Windows IoT device. In order to make this possible, we will be creating a Mariner Linux VM that's highly optimized to run on top of this Windows IoT system. That Linux VM will have direct access to the hardware accelerator card from NVIDIA that will be leveraged by the containers inside it to run AI models. The Mariner Linux VM will be automatically enrolled by Windows IoT Eflow onto an Azure IoT Hub that will be leveraging the Azure IoT Edge component to then deliver containers that will be executed at the edge. Amongst them, this NVIDIA DeepStream container that will be running the model for us. Let's go look at how this is done directly on the demo. So it all starts with a Windows IoT system. Here I'm using Windows Admin Center, which is a tool that has been used for a few years now in order to manage these systems. Here I can actually add a new component, and you will see that there is a new type of resource at the end, an Azure IoT Edge resource. When I create this new resource, I'm going to be following a graphical interface that will walk me through the steps to collect all of the information in order to configure a brand new Azure IoT client. We reach this point in which the desktop system has been identified, and we can actually run a detection to see if it is compatible. In this case, I have already installed IoT Eflow here, so I'll just be exiting and going directly to my current installation. Here you can see that the system has been installed, it's actually running, properly authenticated with the cloud. We in fact have created a Hyper-V VM as part of that deployment, and that Hyper-V VM can now be assigned the NVIDIA T4 Tesla card. Here is the identifier for that card, and with this command I'm going to attach it directly to that brand new VM. I can run now that VM, and when the VM boots, it will find that NVIDIA card and I will be able to detect it and use it. You can see here a highly optimized Mariner VM that has detected that card and is booting. Mariner is running inside of that VM, and it's now ready and provisioned. I can actually access this VM directly from PowerShell with this command shell. It's effectively establishing an SSH channel directly into the device, where I can now get information about where was this provisioned. I can see that this device was provisioned to the Santa Cruz IoT Hub, and the device name is HJ NVIDIA Eflow. I can in fact go to the portal and look at that device. Here you can see the Azure portal is seeing it, and the modules for Agent and Hub are running on it just normally. In fact, I can go to Visual Studio Code and I can prepare now a template.json file to deploy a new container on top of it. This is the NVIDIA DeepStream container that's available on the cloud, and I will be downloading and creating an image with it. That container itself contains the tiny YOLO model that will be doing that inference. So I'm going to go ahead and generate the deployment manifest. And once I have the deployment manifest, I can trigger a deployment for a single device. I will select the device that we just identified, NVIDIA Eflow there, and I will do the deployment. You can see that the deployment has succeeded. In fact, on the left, I can see the modules on side of that, and there is the new module that is right now being provisioned. This could, of course, have been done also from the cloud, and in fact, let me refresh the portal, and you can see that Azure IoT Hub is already seeing that that module has been targeted for deployment. It is still being prepared, so let me refresh this, and there you go. The model is actually available now and running. I can now go and check on that module here. You'll see that the module is reported running, so Visual Studio Code is also reporting that model. In fact, what has happened, if we go back to that shell and do a docker ps, is that that Docker image has been downloaded and a container has been created with that identifier. This container is actually exposing port 8554, which is an RTSP port that I can use to see the results of the inferences running on the device. So let me open VLC, put on the address for this device and port 8554 and /ds test, and we can play the output of that inference. You can see here that I'm actually inferencing over 30 cameras where we have a feed coming in. In all of these cameras, I can see that the inferencing is taking place without any issues. So the model is running successfully and inferencing. Let me go back to that command shell. This is a fully functional VM, so I could even deploy more containers. In fact, let me go ahead and download a new container from NVIDIA. I'm gonna type it here. So this is a performance benchmark container, so I'm going to be running it locally. You can see how we're downloading it, and we're going to be inflating it. This benchmark tool will allow me to see whether the NVIDIA T4 system is running as appropriate. You can see that the video continues to execute in the background, and now the container has been executed, and it's actually providing decent performance, about 20 flops per interaction in this case. Let me actually deploy yet another container, and this time I'm going to get more details on that card. You can see that the NVIDIA card is running there. This is a Tesla T4 card, so the system is fully functional and inferencing. All of this was done using Windows IoT Eflow. Let us recap what we have seen so far. Windows IoT Eflow gives you access to the best of Windows IoT and Linux in a single device that is easy to deploy and manage using the Windows IoT tools that you already know and love. Not only does it deliver a fully functioning high-performance Linux VM, but it also attaches it to an Azure IoT Hub, allowing you access to not only the broadest AI set of solutions, whether running in Windows or Linux, but also Azure IoT workloads that can now be delivered to your device. This functionality is available in public preview. You can read more about it by looking at this blog post and provide us some more feedback.